All right, so we're going to start this section off with polynomial long division. And this is very similar to long division that you would do with numbers. We're going to set it up the same way. I've got my problem over here, number 1, and I have x squared plus 5x minus 14 being divided by x minus 2. So you have to recall that your divisor comes after the division sign, and that's going to go on the outside of the division bar. And then your dividend goes underneath the division bar. And so we're going to start off by taking the lead term, the highest order term, which in this case is this x right here, and we're going to divide it into the highest term on the dividend, which is in this case the x squared. So this is where we start. So we say how many times does x go into x squared? So x squared divided by x would be x. Now, instead of putting my x over the lead term, I'm going to put my x over the term that it matches. So here are my x terms, and so I'm going to put that x over top of that. So that's a little bit different than the way we do it in long division. Usually in long division, you would put it over the number that you divide it into. We're just going to slide it over and make sure the terms match. So you want x's on top of x here. And then we're going to go through and multiply just like you would do in long division. X times this first term is x squared. So I'm going to write that here. And then x times negative 2 will give me negative 2x. All right, and then I'm going to combine those. Subtract those. And I will end up with obviously a 0 here in that x squared term, and I'll end up with 7x here. And then I'm going to bring down the next term, just like you would in regular long division. Okay, so now I have this binomial. I'm going to go back up to the lead term in my divisor, which is this x. I'm going to divide it into the 7x right here. So x goes into 7x, positive 7 times. I'm going to write that up here in the quotient. And I'm making sure, it works out now. As soon as I get the first term in the quotient in the right spot, the rest will work out. But you can see that this is now the constant is over top of, the constant in the quotient is over top of the constant in the dividend. And then I'm going to multiply that 7 by the x to get positive 7x here. And then 7 times negative 2 will give us negative 14. All right, again, I'm subtracting these. So because I'm subtracting these, I didn't really show you up here, but I'm subtracting 7x minus 7x. That gives me 0x here. And then negative 14 minus negative 14 is really going to be, let me change colors here. So it's really going to be plus a negative here and then plus a positive over here. So you've got to remember that when we change this to an addition sign, it changes the signs on both the terms after it. We'll combine those together. I'm going to end up with 0x and a 0 for my constant, so my remainder ends up being 0. So my final answer is x plus 7. So what that tells me then is that the two factors for x squared plus 5x minus 14 are x minus 2 and x plus 7. Now they didn't ask us what the two factors were. They literally asked us for the quotient if you divide this polynomial by x minus 2. So our answer for that quotient is really x plus 7. But if you think about it, if we used long division here to actually factor x squared plus 5x minus 14 into its two binomials, because x plus 7 times x minus 2 are the two binomials that if you multiply them back together, you would get the original trinomial that we started out with. So kind of just keep in mind, even though they're really asking for the quotient, which is x plus 7, we really have the factors, the two binomial factors that make up that polynomial. All right, we'll do that again with number 2. So x squared minus 2x minus 48 is being divided by this binomial x plus 5. So we're going to start by dividing x squared by x. That is x, but we're going to put it over top of the same degree term. Then I'm going to multiply x and x squared, x and positive 5, give me 5x. I'm going to subtract those. I'll get 0x squared, and I'll get 3x. Actually, I will not get 3x. Let me change that. I need to change those signs. So because I'm subtracting, this is going to be plus a minus, and then plus a minus over here again. So I'm going to end up with negative 7x here, minus 48. Go back, do the same thing again. This is now my new dividend. I'm going to take x, or negative 7x, and divide it by x. That'll give me negative 7. I'm going to put that over top of the constant in the dividend as well. Go and do my multiplication. I end up with this. All right, so just like in normal long division, we subtract those two. When we do that, though, we have to remember that we really need to add the opposite of. So I'm going to change those two signs. This will zero out the x terms, and I will end up with a negative 13 here. I have nothing left to bring down. So there's no additional term out here. So you know in normal long division, when you get to that point, that's your remainder. And so this is actually, this negative 13 is our remainder. We have to put that negative 13 over x plus 5 though. So the final answer would look like this, x minus 7 minus, because this is a negative 13, minus 13 over x plus 5. So this is actually the factor, the answer over here for number 2. This is the quotient for x plus 5 being divided into that polynomial. Now, once again, if we multiplied x plus 5 times x minus 7, those two are factors, and then minus 13 over x plus 5, we would get our original polynomial back. So just try to keep in mind how all of this is sort of connecting in with factoring trinomials. Now we can do the same thing using synthetic division instead of long division. So this is a few sections back we learned how to do synthetic substitution. And so we're going to apply that concept here to number 7, where they ask us to divide again, but this time we're going to use synthetic division. And so in that case, we're going to set up that kind of half rectangle, and we're going to look at our trinomial, and I'm going to pull out the coefficients. So I've got a coefficient of 1, coefficient of 7, and a coefficient of 12. All right, there are no terms missing there, so we don't have to hold any spots with a 0. And then I'm going to go into my divisor and figure out what I need to write out here on the outside of the rectangle, what I'm actually going to be dividing by. And so the only thing we have to remember here is that in synthetic division, you want your divisor to be written as a with a difference sign in between. So I'm rewriting that x plus 4 as x minus a negative 4. And then I'm going to take that negative 4, and that's what I'm actually going to do the division by. So I'm going to stick that outside that box. If you remember, in synthetic substitution, our first step is to drop this first term down right beneath it. And again, remember, I'm multiplying when I go around this corner. So now I'm ready to start. Negative 4 times 1 gives me negative 4. I'm going to stick that under the 7. And I'm combining, I'm adding these up. So 7 and negative 4 give me positive 3. I'm going to go back, do the same thing. Negative 4, go around the corner, multiply by 3. That gives me negative 12. And when I add those together, I get 0. So that tells me that I'm not going to have a remainder. My remainder is actually 0 in this case. So to actually translate this into the binomial that is a factor of x squared plus 7x plus 12, we have to actually put that into the way we're going to do that is take those coefficients. This first one is a coefficient of 1, and I'm going to stick it 1 with that x term. Remember, I'm always going to be going, it's going to be 1 degree less than what I divided by. So what I divided by over here was an x squared, okay? So it's going to be 1 degree less than that, which is going to be an x in this case. This is a positive 3, and I don't have a remainder. So the answer, the quotient for this problem is x plus 3. Again, if I took x plus 3 and I multiplied it by x plus 4, I would get what I started with, this trinomial. So these, I essentially just factored it as well as finding the quotient for this problem. All right, we'll do the same thing for number 8. I'm going to write the coefficient. Well, first I'll draw out my little half rectangle, put the coefficients here, being careful to be mindful of the fact that all the terms are there. So I don't have to hold any spot with a 0. My divisor is written as a difference, so it's x minus 1. That means I'm going to take whatever is after that minus sign, and that's going to be what I'm going to divide by. I'm going to drop that first term down here, and I'm just going to remind myself with a little multiplication sign at the corner. So now I'm ready to start. 1 times 1 is 1. I'm going to put that under the negative 3. Add them. 1 times negative 2. Negative 2, add them. 1 times 6, 6, and I'm going to add those together. And so this right here tells me that I'm going to have a remainder. Okay, this didn't zero at the end. The last term didn't zero out, so I'm going to end up with a remainder. I've got to go back and look. Here my lead coefficient has a degree of 3. So my lead coefficient on my quotient is going to have a degree of 2. The coefficient is 1, and then I'm going to go down in order from there. This is minus 2x plus 6 plus this remainder right here. So I have a remainder of 1, but I've got to remember that I actually am dividing by this x minus 1 here. I'm just doing it in an easier way. But when I go back in to write the remainder, I need to put that divisor in the denominator. So that's the final answer for number 8. So on number 11, I already have it set up. I want to show you how to finalize this answer. So I'm just going to go through quickly and do the math here. I'm going to put 6 here for a negative 5 there, negative 15 here, which is going to give me a 0 here, and that's what I want to show you how to deal with here in a minute. I'll get a 0 here, a 6 there, positive 18, and a 0 here, which just tells me, that last 0 tells me there isn't going to be a remainder. So we're going to go back, look at our highest degree on the polynomial we divided into, which is x to the 4th. So that means my highest degree is going to be x to the 3rd in my quotient. I'm going to pull that coefficient of 2 down right there. And then I'm going to say minus 5x squared. I'm just going down 1 degree at a time. Now I have 0 here, so that really means plus 0x. I don't need to write it in though, because we don't typically write in when we have a 0 coefficient. I'm going to do it just right now, just to hold that space to show you. And then there's my constant, no remainder. But the final answer, we would want to take out that 0x, and we would just end up with this right here. Okay, now in 13 and 14, you're going to be doing the same thing as up above. You could use long division. We're going to use synthetic division to complete it, just because it's faster and easier. But just understand both ways will work. They do the same thing. Synthetic is just faster and a little less confusing potentially. They've given you the information a little bit differently. They're telling you that you have this polynomial, x cubed minus 3x squared minus 16x minus 12, and that one of the factors is x minus 6. So that's going back to why I was saying keep in mind what we're doing here, which is really, we're really factoring these polynomials into their binomials that you can multiply together, okay, to get them. All right, so keeping that in mind, that if we know one of the factors is x minus 6, if we use that as a divisor and divide into this polynomial, we'll get a quotient that will give us another factor for it. So that's what we're going to do. They have told us x minus 6 is one of the factors, so we're going to divide by that. So I'm going to make my box just like I did at the top. I'm going to put my coefficients in, making sure that they haven't skipped any terms, which we haven't. And I'm going to divide by x minus 6 means that that's already written as a difference, so I'm going to just grab that 6. I'm going to pull the 1 down, and I'm going to remind myself that I multiply when I go around the corner, and then I'm going to do that math, same math we did above. I'm going to do it quickly just for time's sake. All right, that 0 means I'm not going to have a remainder here. I'm going to go back to my original polynomial. My highest degree is to the third, so that means this highest degree is going to be squared. Coefficient is 1, and then I'm going to go down in order from there. Okay, so now I know that I have this, and if I multiply it by x minus 6, I'm going to get that trinomial, that 4 term to the polynomial over there that we started with. Now here's where it gets a little bit trickier, is they told us to factor it completely. We've got to go in here and look at x squared plus 3x plus 2 and recognize that that can be factored again. Okay, factors of 2 that add up to 3. That would be 2 and 1. So I'm going to say x plus 1 times x plus 2, and then not forget this factor that we already had out here. So this answer is correct. This answer right here, though, is factored completely. All right, number 14, same thing again. I'm dividing because I know x minus 10 is one of my factors. So I'm going to divide synthetically with that 10. I'm going to write my coefficients out. Again, they have not skipped any degree, so I don't have to account for that. I'm going to pull the 1 down, and I'm going to multiply. Doing that math again quickly for time's sake will give me this right here. Remainder of 0 once again. So I'm going to go back over to my polynomial. See, my highest degree is to the third, so I'm going to lower this 1 degree to the second. So here's one of my factors. The other one was this x minus 10, which is what I divided by. Again, though, they told us to factor f completely. So I'm going to look here and see, are there factors of -8 that when I add them together give me -2? The answer is yes. -4 and +2. So I'm going to write those two out. Okay, and then add in that the factor we started off with. This in the box is factored completely. This is correct, but we have to follow the directions to factor completely to get the final answer. All right, in 19, the directions change a tiny bit. Actually, the directions don't change really. What changes is the way they present the information. So they give you a polynomial. They tell you that instead of telling you one of the factors of that polynomial, they tell you one of the zeros of the polynomial and ask you to find the other 0. So just to kind of refresh your memory on this, to kind of hopefully to connect the dot a little bit, if I gave you a problem that asked you to factor it, let's just go back to the one we did above where you had to factor completely, and let's say I asked you to factor this trinomial right here. You would factor that into x plus 1 times x plus 2, and assuming that I had told you that equals 0, that's important. Okay, you knew that whole thing equaled 0. Then you could set each of these binomials equal to 0, and you would solve for the zeros of the function. And you know the zeros of the function just mean where the function crosses the x-axis. So zeros of the function mean the x-intercepts. So we've got to keep that in the back of our head when we're doing this over here on number 19. We'll come back to that. So on number 19, they told us one of the zeros is -6. And so we can, when they give us information in that way, not the factor, they didn't tell us the factor was x plus 6 and ask us to find the zero. They went ahead and solved for x and said x is -6. That's one of the zeros. So when I set that up for long division, synthetic division, I can just set that outside that rectangular box like this. All right, put my coefficients in there. And then bring this down, remind myself I'm multiplying, and again, quickly go through that math just because I think that this is pretty straightforward at this point. Okay, and then I'll end up with the remainder of 0 again. We're going to go back, look at our highest degree, which is x to the third. That means this is x to the second minus 4x plus 4. All right, so there's one of the factors, and then the other factor is x plus 6. All right, the reason it's x plus 6 and not x minus 6 is because they had already solved for the 0 here. They told us the 0 was -6, which means x equals -6. That's like up here, if you had gone through and solved, you would get x equals -6. Well, if x equals -6, that means that if I want to go kind of backwards and put it in this step back into the factored form, this would be x plus 6 equals 0. So this x, that's why this binomial right here has that plus sign in it. So now I have these two terms. They asked me to solve for the other 0. So I have to factor this right here into its components, which is x minus 2 times x minus 2. All right, and I can just kind of pull this down just to keep it consistent. All right, so that whole thing, I'm going to solve for the zeros. That one right there is kind of redundant because I already know that x equals -6, and here I know x equals 2. I only have to do one of those binomials because they're both the same. So the other 0 is x of 2. Now we're going to go through those same steps again for number 20. They told me one of my zeros is -14. Write the coefficients in. Drop the 1 down. Multiply. So doing the math quickly. All right, unfortunately we get another remainder of 0. All right, so go back to my polynomial. Highest degree is this x cubed, so I'm going to make this one lower, x squared minus 3x minus 108. There's one factor. This right here was my 0, so that was my already solved for x equals -14. If I want to go backward and get the actual binomial that's a factor, then I'm going to add 14 to both sides. I'm just going to go backward and make it equal to 0 there. So that means that my other factor was x plus 14. Okay, so this is the factored form. You can see though, even though it's a -108, you can probably tell that this can be factored. Factors of -108 that add to -3 would be x plus 9, x minus 12, and then of course I'm just going to write this in here, this x plus 14, just to keep things consistent. A little bit redundant here though, because we already know that x plus 14, this is going to give us -14. I'm going to set that to 0, get a -9, and this will give me a +12. So the other zeros besides the -14 are the -9 and that +12. Now in number 25, they have given you an expression for the volume of that box, and they've asked you to find the missing dimension, which happens to be the height in this problem. So really all volume is a product of 3 factors. This 2x plus 1 times the x minus 4 times whatever this height is. So we can use one of these factors, and we're gonna pick this one right here, with the one that has the degree the smallest degree on it, and we can divide that factor into this polynomial, into the volume, and find, use that to find the missing factor here, okay, the missing dimension of height. So that x minus 4 is already written as a difference, so we're going to just pull that 4 to divide into that polynomial. I'm going to put the coefficients up here of each of those terms and bring the 2 down. And again, I'll quickly go through this math. So I'm going to end up with again with a remainder of 0. Going back to that volume polynomial, I'll see my highest degree is an x cubed. So this term then is going to have a coefficient of 2, and the degree on the x is going to be squared, minus 3x minus 2. So here's one of the factors, and I can't forget that I divided by this x minus 4, okay? And what I'm going to need to do here is factor this out so that I can get the polynomials, the two binomials that multiply together for that. So this lead coefficient is not 1, so I'm going to multiply 2 and negative 2 together to give me negative 4. Factors that add together or multiply together to give me negative 4, that add together to give me negative 3 would be negative 4 and 1. So I'm going to rewrite the first term, write the middle term as a sum of negative 4x and positive 1x, and then copy down that minus 2. I'm just dropping that down. We can't forget about this not x plus 4, this x minus 4 over here. But I'm just going to keep dropping it down. All right, I'm going to group these off. All right, so we've got 4 terms. I've got to factor by grouping, pull out what's common to both. I'm going to pull a positive 1 out there, and then I'll end up with x minus 2 times 2x plus 1 times this x minus 4 over here that I just didn't rewrite it on this line right here, but it's still there. I'm just pulling it down. So that tells me that there's that factor, that width of x minus 4. Here's my length, 2x plus 1, so those two match. And here's the new dimension I came up with, which is that x minus 2, and that goes in right here for the height. So those 3 terms together will multiply together to give me this expression for volume. So when they say find the expression for that missing dimension, though, the actual answer is this x minus 2.